Hi guys, Buildzoid here, and this is going to be a really random video just because I just saw I saw Major Hardware test a Peltier for like CPU water cooling, and it was like, and I keep seeing people run Peltiers, and they keep getting really surprised that it like doesn't cool as much as like as much as they thought it would, and and it's just like, yeah, that's because you never did the math on any of this, right? Like that's the main issue. Is a lot of people that they see the Peltier documentation, and so here we have, like, I'm not saying this is a Peltier I would recommend. I just went to DigiKey and I sorted for some high power Peltiers with relatively like low operating voltages, which this is a 15.4, so even if you ran it off of 12 volts you would be undervolting it a little bit, but that wouldn't really make too much of a difference. Anyway, so yeah, we have this Peltier here, and the reason I didn't just grab like a data sheet for a random Peltier from like eBay, because there's some really cheap ones that you can get, and the thing is just like, I wanted, you know, some more reputable manufacturers, so that's why we're not using like an eBay Peltier data sheet. But anyway, so here we have our Peltier data sheet, and so the thing is, input voltage 15.4 volts, 18 amps max current draw, so pulls a lot of current. It's a 0.66 ohms resistance, which actually we can calculate from that how much power it would be pulling at 12 volts. So if we take our calculator, right, we go 12 volts divided by 0.66 times 12. Oof. Like, just oof. That's 200 and... wait, we'd be going out of spec back, wouldn't we? Typical resistance. Wait, there's gonna be so... No, it's maximum... It's not working out. Like, it shouldn't be able to pull... Oh, wait, max output. Oh, no, no. Okay, yeah, that's fine. I was a bit confused because I was like, wait a minute. It's supposed to... No, no, this is fine. Yeah, it would pull 218 watts, and at best, you would get 172 watts of pumping power. Maximum temperature delta for a hot side temperature of 50 degrees is 75 degrees. For a hot side temperature of 27 degrees, you get 68 delta. So basically, like, let's say let's just do something really incorrect. So we take our 27-degree hot side and we're just going to subtract our 68, you know, temperature delta, and it's like, oh my god, if we keep the hot side of the Peltier at 27 degrees, we can hit minus 41 degrees. It's like, this is really freaking cold, and it's like, yeah, that's really really cold. There's just one tiny little detail that most like that's a major issue here. Peltiers don't work like that. They have a performance curve, and every Peltier data sheet is going to have one. It looks something like this. This is the part that basically screws you over with any Peltier. So, as we can clearly see here, that maximum, so this is the temperature delta for 27 degrees. This is for, T hot of, so that's the hot side temperature, right? That's what the TH stands for. So hot side temperature of 50, there's our 75 degrees. How much heat is it pumping? 0. Oh. Okay, so basically the only way we're getting minus 41 degrees on our Peltier is if we have it like, if we have a heat, like a water cooling loop on one side to keep it at, you know, 27 degrees, because again, that thing's probably going to be pulling like, what is that? That's 18 amps. Yeah, it's pulling a ton of power. Let's just leave it at that. It's pulling a ton of power. And you know, we're doing our, you know, 200 watts of power consumption plus, and we have it like, so we have a water cooling loop on it to make sure that the temperature doesn't go above 27 degrees on the hot side, and we put it up against like a pillow or something, and that's the only way you're getting minus 40 out of it. So that's not practical, right? And if the hot side is at 50 degrees, then our minimum temperature is minus 25 degrees instead of minus 41 degrees. So that's a real problem. Now, let's consider a CPU like I don't know, a 3800X, right? This might be a CPU that, in my, like, out of the modern CPUs available, that is probably the best candidate for a Peltier because, well, it's a relative, or a 3700X. Actually, a 3700X is a far more reasonable CPU. But the main thing for me was it's an 8-core, 7 nanometer CPU. It doesn't pull that much power. It does run really hot. It's hard to cool. It's annoying to cool. So this is a great candidate for a Peltier, right? Because because we could benefit from some lower temperatures. Now the problem is an overclocked 3700X is like 100 watts of CPU power consumption. So our 100 watt CPU power consumption. Okay, so if we want to move 100 watts, and we're going to be using like 12 volts here, so we're going to be between that 14.4 and that 10.8 amp. Actually, I should zoom in a bit, right? And we're going to go with the T-Hot of 50 because keeping a Peltier, like keeping a 200 watt heat load at 27 degrees, very, very difficult. Keeping it below 50, much more reasonable. So we're going to use the 50-degree performance curves, and we're going to assume I would expect, like, if you built like a custom water cooling loop for your Peltier, you should be able to hold it at like 45, 50 degrees. If you try to air cool it, it's going to go over, it's going to hit like 60 plus degrees and you're screwed. Not because it's going to kill the Peltier, but if the Peltier is above like 60 degrees, then like sure, your temperature delta actually increases as your hot side temperature increases, but if you're starting at 60, you're gonna have to drop like what? Well, a lot of degrees before you get down to like a useful low temperature. So anyway, with our 3800, 3700X, which is like a 100 watt CPU, on 12 volts, we would be looking at, with one Peltier, we'd be looking at this line right here, around that 120. Well, actually, we'd be right around here in the middle. So we'd be looking at like, oh, I don't know, a temperature delta of like 10 degrees. Okay, so that's completely useless. So if our hot side is at 50 degrees and our cold side is at 10 degrees below that, we are now at 40 degrees water temperature because our CPU outputs 100 watts of heat. Yeah, this is not working. We need more Peltiers. Obviously, what we need is more Peltiers, right? We need to spread the heat load across multiple Peltiers. So, if we add a second Peltier, we drop our heat output down to like 50 watts, which I think would be like somewhere around here. Now we get a useful temperature delta of like, oh, 40 degrees. That's actually not bad. So yeah, with like two of these, while pushing, like the thing is, again, we're gonna be above that a little bit because we're gonna be at, so let's just call it like 12 amps, right? So pushing like 144 watts into each Peltier, so a combined Peltier power consumption of around 288 watts. We're gonna be getting a water temperature of like 10 degrees. So that we can cool a 100 watt CPU with water that is slightly colder. Like, this is the issue. You need, like, for any amount of CPU power consumption, like basically the minimum amount of Peltiers you need, it is at least 2 times the power consumption of the CPU. If you actually want to go like approaching 0 degrees, right? Let's say we wanted to push down all the way to almost 0 degrees with our Peltiers. Well, we would need to be hitting like this right here, this line right there. So that's like less than 40 watts of heat per Peltier. That's going to be like, I don't know, that's like 30 or something. Let's call it 30. So we would need like 4 of the damn things to cool a 3700, to get the water temperature going through our water loop for our 3700X down to 0 degrees. And that's not including the heat that the pump is dumping into the water loop, and also the fact that the water loop is like leaking heat in from the atmosphere, right? Because the room temperature is above the water temperature, so naturally the heat from the room is going to be sinking into the cold loop. So you want to keep the cold loop as short as possible and as small, well, not necessarily as small as possible in terms of water volume, though that'll obviously change how quickly it like heats up and cools down. But like because the thing is, you can store a lot of volume with a relatively low surface area. You want to minimize the amount of surface area between the cold loop and the ambient air. Because the more surface area is in between the two, that like the more heat you are, well, the more cold you're losing to just the environment. So yeah, Peltiers kind of suck. So here, if you wanted to, push a 3700X to 0 degrees water temperature, you would need like four Peltiers pushing, 12 amps at 12 volts, like 144 times, well, no, times 4. Yeah, you'd be pushing like 500 watts of Peltier power consumption to get your 3700X like 20. Well, the thing is, even if you build like a really big custom loop, most of the time you're gonna bottom out at like 5 degrees above ambient or like a couple degrees above ambient. At the end of the day, unless your radiator is just absolutely ridiculously huge, you're gonna be at least a couple degrees above ambient. Um, most like AIOs and stuff run like 10 to 20 degrees above ambient. As in, if your room is at 20 degrees, then your water in the loop is at like 30 to 40 degrees. Depends again on the heat output of the CPU, though a 3700X doesn't put out that much heat. So the water loop, like your AIO, I'd expect your AIO to sit somewhere around 30. With something like a 10900K, AIOs end up in like the approaching 40 degrees water temperature quite quickly. Um, but yeah, so anyway, yeah, that's my point, right? So, comparing to an AIO, yeah, you're like 30 degrees below AIO temperatures. You're like 25 degrees below a custom loop, probably. So yeah, but you're burning 600 watts of power. And also keep in mind, those 600 watts of power need to go somewhere, and they're going straight into your room. So, like unless you're doing this in winter and you're dumping maybe you're actually, if it is cold where you live, you could like have the Peltiers, like the Peltier cooling system, pulling in air from the outside, heating that up, so you get fresh warm air, right, in winter. You don't have to worry about having a window open anymore because your cooling system's so bloody inefficient. Anyway, so yeah, so that's the basic issue with Peltier cooling. You need multiple times more wattage in Peltiers than what you're cooling. Okay, like that's just kind of a fact with Peltiers. You're going to be looking at if you want to drop the temperature slightly, you're going to have like twice as much power consumption in your Peltiers. If you want to significantly drop the water temperature, you're looking at 3, 4, 5 times more power consumption. Also, if you're going to overclock, like the main reason why you would, get a Peltier cooling loop is probably because you want to push your overclocking even further. And the thing is, as you increase your overclock, your power consumption goes up. So, you're probably going to end up turning your 100-watt CPU into like a 130-watt CPU, and now you need another Peltier, right? So like this gets really out of whack really, really quickly. But anyway, one thing that's kind of interesting about Peltiers is you'll notice that the actual efficiency here, like if you read into the graphs a bit, the efficiency here actually improves as you undervolt them a bit. So if we look at like this 24 volt model right here, which pulls less current, has a lot more resistance, but the actual total power consumption, like maxed out, this thing is still going to be pulling an absolutely stupid amount of power, right? That's a 24 amps times 24 volts times 13 amps. That's a 300 watt Peltier for a maximum, pumping capacity of 200-ish watts. So that's not very practical. But if we undervolt it, and we zoom in a bit, so if we undervolt it down to around 12 volts, it'll probably be pulling like that's 7.8, so that's like 8 amps, and that's like 5 amps. So 6.5 amps is roughly what it's going to be pulling well, actually, this is almost 12 volts, so we'll call it 6 amps, okay? So it'll pull like 6 amps on 12 volts, so 6 times 12, which is not much. Yeah, so that's like 72 watts, and that's not too bad. And this 5.2 amp curve right here, so, and this is for T-hot of 27. Okay, well, you're not, like, it's not that hot, but you're not keeping it at 27 degrees. That's, like, the issue is not that you can't have, like, if you're air cooling your Peltiers, there's no way you're getting, like, no way you're getting 27 degrees whatsoever. With a water cooling loop, hitting 27 degrees water temperature is not hard, but you still have the issue of like, okay, well, the water's at 27 degrees or 25 degrees, but then you have the thermal resistance of the water block and the thermal paste and the contact quality between your Peltier and your water block, and it's like, okay, no, you're not like. It's hard to get a Peltier this cold. So again, we're going to look at the 50 degree curves because those are far more realistic for any kind of application for the Peltiers, like any kind of cooling system that you ultimately end up building. So that 5.2 amp curve, right, like 5.2 amp line, it's not really, yeah, it's a line, not a curve, but Anyway, that ends up with a max delta of like 55 degrees. That's not actually that bad, right? That's not completely terrible. And, 12 volts, 5.2, it's actually, now it's like 5.2 amps. So let's say we want a 40-degree delta. That's like, that's almost 50 watts of capacity right there, right? 40-degree delta. Admittedly, this is like 10 degrees water temperature, so we're kind of screwed. Like, this is not much of an achievement, right? We're pushing our like again, you have the Peltier to water block heat transfer losses, but like, yeah, you might be able to hit like 10 degrees water temperature. If you decide to go maybe 15 degrees water temperature, then we get like 50 watts, right? Like that's right there. And if we go up the graph, then at 12 volts, that'll be like 5.3 amps, a little bit more than what we have for the actual line. The line itself is 5.2 amps. Um, which if we do that 5.2, or if we do 5.2 times 12, that's 62 watts of heat for, what is that, 50 watts worth of actual pumping capacity at 35 degrees delta. Our efficiency is finally not completely crap, right? Previously we were talking about like 100 plus watts of Peltier power consumption to pump 50 watts of heat. So we were pumping, or not even to pump like 50 watts of heat, and our temperatures were garbage. Or we were pumping 35, 30-ish watts of heat, and again still pulling like 100 watts worth of Peltier power, over 100 watts worth of Peltier power. But if we undervolt our Peltier, the efficiency goes up a bit. Our max temperature delta goes down, but that's fine. We couldn't, like, you can't achieve that peak minimum that absolute minimum maximum. Well, you can't achieve that peak temperature delta anyway. It's not really a useful thing for any kind of high power consumption cooling application. So if we took this 24 volt model, we could get around here, which 35 degrees. So if, yeah, we would have like 15-degree water temperature maybe. So like this part of this range right here is kind of usable, and our Peltier is only pulling like 62 watts, which is no longer completely ridiculous. We get up to maybe 50 watts of pumping capacity. So now we would just need like 120-ish, yeah, like we could now cool our 3700X with just 124 watts worth of Peltier. If we, increase that up to, like, if we get 3 Peltiers, we could actually maybe get like 10 degrees water temperature at full load. And admittedly, we'd be using like 62 times whatever, times 3, like 186 watts to cool our 3700X. But, this is not a completely, like, this is not the same, like, not as bad as the 600 watts we were talking about previously. Admittedly, there I was aiming for actually like 0 degrees water temperature, but hey, let's see if we could do 0 degrees. Whoa, that's like 10 watts. So you'd need like, okay, no, you'd still end up like 600 watts of Peltiers. So yeah, this still doesn't work out if you want 0 degrees. So basically, Peltiers are completely useless if you're trying to hit like 0 degrees water temperature for a high power consumption application. Now, if you wanted to freeze the crap out of some memory sticks, these guys doing like going full bore on one of these, yeah, sure, you're gonna freeze the crap out of any memory stick. In fact, if you got an even lower voltage model, which let's try that. So I'm gonna get rid of this. I'm gonna get rid of the Qmax. I'm gonna pick like a model that's really. We don't want to overvolt it. We want to hit exactly the maximum voltage for it. Okay, so what do we have? We have a 23 watt option. That's not big enough. We have a 60 watt option. Oh my god, that thing is so expensive. Wait, what is this? Is this some stacked monstrosity? 35 degrees, Qmax, delta. No, this is a pretty standard. Why is it so expensive? Oh, it's like a. Oh, that's very fancy. Wait, does that come with a water block? Or... Okay, let's take a look at one of the cheaper ones. Let's take one of... Yeah, let's just go with... That's a 23. You'd need a bunch of those, but that's fine. Actually, this one has a really nice delta at 27 degrees. Oh, wait, it's 2 Peltiers on top of each other. Oh, well, that's fun. Yeah, if we want to like again, if we want to freeze the crap out of a memory stick, this is going to be great. Or a bunch of memory sticks. Like it's not even that big. It's a 50 by 26 millimeters. So I think you could stick. Yeah, you should be able to get like two of these on top of a memory stick. Um, if you use like one of those memory water blocks with the memory heat spreaders for water blocks, you could totally get like two of these onto a memory stick. Or actually, if you were using these to cool a loop, you could get probably like four of them. It would be like really the efficiency would be a disaster. Actually, yeah, because that's 5 amps times 12 volts. That's going to be like 60 watts, and you get like 23 watts of pumping capacity or 25. Yep, that's great. That's exactly what we're looking for. But here we have our lovely performance curves. And the cool thing here is like memory sticks don't pull that much power. So like yeah, like you would freeze the crap out of a memory stick. Right? Like if you're especially if you're going for like frequency validations or something. Okay, that's for 27 degrees, but if we were at 50, and like 12 watts is enough for like three or four memory sticks. Like that is even if you're overvolting the memory sticks, like you could use just one of these modules and you could do two memory sticks at the same time. Um, so the thing is, you obviously have thermal losses through the motherboard because the memory stick is connected to the motherboard. The motherboard has a lot of surface area relative to the ambient air, so that's not great for your overall efficiency. But, you know, at this point, like, efficiency went out the window when you decided to stick a 12 volt 5 amp Peltier onto your DDR4 memory stick. like, like, at this point, we're not pretending that we're going to be efficient. Um, so anyway, we're going to take our lovely 4 amp curve because apparently, yeah, that's closer to the 12 volts. So that's 48 watts. And if we go, yeah, we could do minus 20 degrees with one of these. And I think, like, I'm pretty sure you could put three. Well, if you're putting them into a like water loop cooling system, you could totally stick like four of them into the system which you know you'd be burning what like 200 watts of power, but your memory sticks would be ice cold, like totally worth it. Actually, below ice cold, like yeah, you could freeze the crap out of a memory stick with these. Actually, if you're idling the memory sticks, because the thing is, memory sticks actually, you know, they have a idle and a load power consumption. Like if you're literally just taking like screenshots of your memory sticks doing high frequencies, yeah, you could probably run your memory sticks down to like minus 30 or something which is, you know, not too bad. So, yeah, so these are fun. Except they're, of course, very expensive because this is actually two stacked Peltiers together. Um, yeah, two stage control. Yeah, the main reason why Peltiers exist is because they're very precise in terms of the temperatures. So they're primarily used for, you know, cooling very temperature sensitive but low power devices. Um, which I think like laser diodes are a popular application for them, but I don't know that much about that. Like I've only ever looked into Peltiers as like I totally like I want to cool my CPU without having to figure out how to do like proper refrigeration because that's you know very complicated and expensive. Whereas this, like, yeah, this actually, like, initially you might be like, oh, this is totally going to be cheap, and then you end up like, okay, so now we need my, you know, like a 600 watt water cooling loop is actually not that cheap. You need a lot of radiator for that much heat output. Um, so initially you might be like, oh yeah, I'm just going to use like these $5 Peltiers, and then you factor in like, oh, I'm going to also need like $300 worth of water cooling loop or well, I guess if you were going for second-hand radiators and you didn't care about the radiator size, like if you just grabbed any radiator you could get your hands on, you might be able to do it with like sub $200 for you still need the water blocks for the Peltiers though. That's the other annoying thing is like now you also like if you have 5 Peltiers, that's that's you need a water block for each hot side and cold side. You're going to be looking at like if you're going to maybe you would use like memory stick water blocks, which you can fit like two Peltiers under one of those. Assuming you're talking like 50 by 50 or 40 by 40 millimeter Peltiers. Um, so yeah, like these are fun, but like please just if you're gonna like, I think Peltiers are cool. I'd love to play with them, but again, it's just like every time I priced it out, it's like before you get a useful cooling capacity out of them, they pull an insane amount of power. They need a ridiculous amount of cooling because of the power consumption, and the price actually ends up being kind of ridiculous. Now, admittedly, I'm looking at Peltiers on DigiKey. DigiKey is definitely not the cheapest place to get your Peltiers. Um, again, if you go on eBay, you can get like 100-watt modules for I think like $10 or something. You can get them really, really cheap. But the thing is, they still all like the thing is, I think the sketchy eBay models have even like I think those might have even worse efficiency. So, you might need to go even heavier. Like the documentation won't necessarily be so accurate for those, but still, like ultimately the thing is, regardless of if you're buying like expensive or cheap Peltiers, the main issue with them is you will need like multiple times the Peltier power consumption in order to get any useful cooling out of them for your device. So if you have a 100-watt CPU, you're probably looking at like 300, like, well, depending on how you're running the Peltiers, you're looking at anywhere between like 200 to 600 watts of Peltiers before you get, useful cooling out of it, which is ridiculous. If you're looking at cooling like a 200-watt CPU, you're looking at least 400 watts to, 800 watts of Peltiers. If you wanted to water cool a GPU, I mean, Peltier cool a GPU, um, you've got issues at that point. That's not reasonable at all. But because the thing is, like GPUs, like if we're talking a high-end GPU, because I'm assuming you're not gonna like Peltier cool your HD 7870 or something. Well, actually, I would totally do that, but because that's actually reasonable. That card doesn't pull in like that card is roughly 150 watts. So yeah, with like a 600-watt Peltier loop, assuming that you're running slightly undervolt, like if you're running undervolted Peltiers, you could actually get somewhere with that. Or 800-watt loop at full voltage. um yeah, you could get a HD 7870 very cold. But if you're talking like 7970s, 290x's, Vegas, Furies, 2080 Ti's, 1080 Ti's, 980 Ti's, high-end GPUs which pull 300 watts plus, you're looking at like, oh, I don't know, you're going to start at like 600 watts worth of Peltier up to 1200 watts worth of Peltiers. Like, you're going to need. Oh, and that's the other fun part is like eventually you end up with so many Peltiers that you're looking at your power supply where it's like, oh, I'm going to need a whole extra 1200-watt power supply for the cooling system. Or, and if you wanted to scale up the Peltier cooling system to like, say, an entire computer where you say have one GPU and a CPU, like, no, just no. Like, you don't do that. That is stupid. Um, it pulls way too much freaking power. So yeah, Peltiers are fun. I think they're really cool. Like especially for something like freezing the crap out of a memory stick. I think there's a lot of potential, especially looking at something like this. Like memory sticks. Like I think B-die at what was it like 1.5 volts, two sticks was like 20 watts for the entire memory system. So the memory sticks were probably pulling 10 watts combined. Um, like yeah, with just one of these modules for 10 watts worth of memory stick power consumption, like what is that? At 12 volts, we'd be like down here somewhere, right? We'd be like down here, which is like minus 10 degrees for two memory sticks. And if you went further, you could go, and actually BDI is relatively power hungry. So if you use like some, like depending on which memory sticks you're using, yeah, you could freeze the crap out of some memory sticks. Again, using, like 8 times as much power as the actual memory sticks are pulling. But because memory sticks pull so little power in the first place, it's not really that big a deal, right? Like you probably have 100 watts worth of spare capacity on your power supply, or more than that, depending on what kind of power supply you have. If you're going to be messing with this, if you're an overclocker, I'm assuming you probably have ridiculous high power supplies, just because you might run multi GPU or something, and then you really need a lot of power. So yeah, but for like day to day usage, like replace your custom loop with Peltiers, like because it basically, like, again, with the 3700X you would go from having like you can run a 3700X along with a GPU off of like a 550 power supply or a 500 watt power supply, depending on how much overclocking you're doing and which specific GPU. Well, if you had a low enough power GPU, you could totally do it off of 450. Um, but depending on the PSU, well, like, so you could go as low as like around 500 watts of power supply for your 3700X build. If you decided to run a bunch of Peltiers to cool the 3700X, you'd be looking at like a 700 watt power supply. Like, do you see the issue? Also, your idle power consumption. Well, I get, like, yeah, if you set up some fancy control system for the Peltiers to not run full tilt all the time, then your idle power consumption wouldn't be a total disaster. But the thing is with the Peltiers, like, you would need to keep the water temperature low because they do take, like, water loops. Like, if you decided to, actually, I wonder if you could scale the like running of the Peltiers based on the CPU power consumption, like directly tie it to how much current the CPU is pulling. Because the water should act as a good enough thermal buffer for that to, like, instead of going based on the water temperature, you could predict that the water temperature is going to start rising based on how much power is going into the CPU, um, which would give you slightly better temperature control. Um, at the same time, the other issue is like actually like controlling Peltiers. You can't really just turn them on and off based on if the water temperature is too low or too high, because they are thermally conductive. That's kind of the main limiting factor for their own performance. They are relatively thermally conductive. That's why there's a hard limit on how much of a temperature difference you can have between the hot side and the cold side, because at some point the hot side is heating up the cold side. Um, Faster than the, thermoelectric effect is actually cooling down the cold side. So that's why they fall, like, that's why you get the maximum like, that's what limits their performance. So if you have a turned off Peltier, sitting between your cold loop and your hot loop, well, now your hot loop is heating up the cold loop because there's a turned off Peltier sitting in there. So your idle power consumption would still be pretty awful unless you made like a DC power supply to make sure that the Peltiers are always running, at least a little bit. Because if you just completely turn them off, they do leak heat a lot. So, yeah, I just kind of wanted to talk a little bit about Peltier cooling for computers. So, yeah, and oh my god, this video is 32 minutes. Oh well, I don't know. This might not end up going public. I might just make it a bonus video for the patrons. But anyway, yeah. So that is it for this video. Thanks for watching. Like, share, subscribe. Leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can buy shirts, stickers, posters, all that stuff that helps with supporting the channel. And yeah, that's it for the video. So thanks for watching, and goodbye.